Hi. In this video we're going to keep looking at some applications of linear equations. We're going to look in this video with distance, and I think in the next video we'll look at interest rates. So let's look at just the basic distance formula. We have that the distance an object travels is the rate the object travels at times its time. So distance equals rate times time. Always want to think about it that way. For example, let's say we wanted to go from, say, Wichita to Kansas City. That's about 210 miles. So, we want to go, say, 210 miles. And let's say our average speed on the turnpike is, say 70 miles an hour, average speed. So we might be traveling faster than that during certain stretches. But maybe it takes a while to get onto the turnpike and then off the turnpike, and maybe we want to stop at Towanda or something. Anyway, so the distance 210 miles, and our average speed. So that will be our rate. That's going to be, let's just say that's 70 miles per hour. There's always going to be a time component in the rate, distance per unit time. Miles per hour is typical. We may also have, say, meters per second. That's typical scientific unit. There could be other speed rates, feet per second, used as well. Okay, so the question would then maybe perhaps be, well, how long would it take to get to Kansas City? Well, we could then just set up this equation. We know that it's going to take, we want to go 210 miles. We're going to go 70 miles per hour, and we need then the time it takes to go that distance. So you can easily solve this for t, just divide by 70, right? And we get t equals 3. Right? Well, t would be in the time units of our speed here, so hours, and therefore it would take 3 hours to go from Wichita to Kansas City. Okay, so just a quick example here. Let's look at a more detailed example. Let's say we have two trucks, and they leave a warehouse at the same time. One travels due east at an average speed of 45 miles per hour. The other travels due west at an average speed of 55 miles per hour. All right, and we're asked how many hours will the trucks be 450 miles apart? Okay, I just happened to highlight a few things, but I want to go read this again. And this time we're going to focus on the particular things that I've underlined here. So we've got two trucks. We can imagine that, two trucks at a warehouse. And they leave at the same time. Right? Now that's important. That means if we let a variable here for t be the time, that variable will be the same for both trucks. Right? They leave at the same time. We would not need to, say, offset one of the trucks because it left later. Okay, one of the trucks travels due east. Okay, now we can start to get kind of a picture of what's going on. So let's say we've got the warehouse here. Trying to draw a warehouse. Box type shape. Maybe you've got a door on it. Yeah. And then need like one of those big garage doors so they can get the trucks in and out. Maybe they got one on the side here too. All right, maybe a window for the office. There we go. All right, good. Okay, so there's the warehouse, and we've got east and west. So we've got east this way, west this way. And west. All right, so we've got a couple of trucks. Maybe too many wheels. I don't know. There we go. And another truck. A little bit more fancy truck over here. All right, there we go. Okay, so there's the two trucks, and they're leaving, going opposite directions. Okay, one's going east at a speed of 45 miles per hour. The other truck goes at a speed of 55 miles per hour. and we're interested in the time it takes for them to be, throw that on here as well, 450 miles apart. Okay, so what we want is the distance to be 450, and we want the time it takes for these trucks to get there. So again, we want to go back to this distance equals rate times time. So both of these trucks are traveling at a particular rate. So we can think about this truck moving east at 45 miles per hour. After an hour, this truck will have gone 45 miles. 2 hours, 90 miles. 3 hours, 135 miles, and so on. The other truck heads west, so it's going to go in an hour, 55 miles. In 2 hours, 110 miles, and so on as time moves along. Now, since they leave at the same time, these trucks are going to move east and then west, and then to calculate the distance between them, since they're moving in opposite directions, we would add their distances. Right? So, just for example, after 1 hour, the truck moving east moves 45 miles. After 1 hour, the truck moving west travels 55 miles. In total, they are then 45 plus 55 miles apart. And that would be 45, 50, 90 plus 10 is 100. So 100 miles apart. Okay, now the question is, well, how long until they are 450 miles apart? Okay, we can set up an equation to find that. Okay, so we're interested in the distance. Let's just write that down. Of 450 miles. And our rates are going to be different for the two trucks. So let's write it down. So we've got truck, let's call it truck east. Okay. Is going to have a rate of 45 miles per hour. And the truck going west, 55 miles per hour. All right, and the time is the same, so we'll just let t be that variable for both trucks. Okay. So now we can set up an equation for this. Right. Let's put that over here. So we know that distance equals rate times time. And we have two different rates, and those distances are going to add together. All right. So the distance, that's a squeaky mark. Let me find a better one. Okay, so the distance the two trucks travel, so I'll just say both, it's going to equal to the distance the east truck travels plus the distance the west truck travels. All right, now we want the distance between both of the trucks to be 450. So I'll go ahead and write that in there. And now we need to calculate the distance the east truck goes in amount of time t. Well, distance equals rate times time. Rate 45, time t. Okay, and then we want to add to that the distance the west truck goes. So 55 miles per hour, same amount of time. So 55 t. Okay, and now we just need to solve for t. And this is a linear equation of one variable, and we'll add these together. So 450 equals 45 plus 55 is 100 t, and we'll divide by 100. So t is, and we've got 0 cancels, 45 divided by 10 is 4.5. And the units on this are hours. So in conclusion, the two trucks, or how many hours will the trucks be 450 miles apart? We can answer that by saying 4.5 hours.